The morning air in Toledo, Ohio, carries the metallic tang of welding sparks and hot engine oil. It's August 19th, 1943, and inside the massive Willys Overland factory, a rhythm pulses through the concrete floor like a mechanical heartbeat. One Jeep rolls off the assembly line, 80 seconds pass, another follows, then another. The workers, many of them women, many of them working their first factory job, move with practiced efficiency, their hands guided by muscle memory developed over thousands of repetitions. Bolt, tighten, move. Bolt, tighten, move. The line never stops. Standing near the final inspection station, a tall man with greying hair and sharp eyes watches this ballet of production with an expression that mingles pride and something else, something harder to name. Delmar Girl Roos, universally known as Barney, is 54 years old, the executive vice president and chief engineer of Willys Overland Motors. The vehicle streaming past him every 80 seconds is his creation, though he would be the first to tell you it's also the creation of Karl Probst, Harold Christ, and a dozen other engineers whose names history will mostly forget. But the engine, that stubborn, reliable, nearly indestructible Go Devil engine, that's all ruse. And as he watches another olive-drab Jeep complete its journey from scattered parts to finished machine in less time than it takes to brew a pot of coffee, he remembers another day. July 11th, 1940. The day the United States Army asked him to do something impossible. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The impossible has a way of becoming routine when survival depends on it. In the summer of 1943, with American forces fighting across North Africa and preparing for the invasion of Italy, the Jeep ceased to be merely a vehicle. It has become a symbol, a tool, a lifeline. General Eisenhower will later call it one of the 6 most important weapons of the war. General George Marshall has already declared it America's greatest contribution to modern warfare. But on this particular morning in Toledo, it's simply a machine being built at a rate that would have seemed like science fiction 3 years earlier, one every 80 seconds. To understand how this became possible, how the impossible deadline became an impossible production rate, you have to go back further, not to 1940, when the Army first issued its specifications, not even to 1938, when Barney Roos first walked into the dying Willys Overland plant. You have to go back to Berlin, Germany, March of 1937. At that moment, a brilliant American engineer heard Adolf Hitler speak and decided he wanted nothing to do with the coming war. Barney Roos was not a man easily impressed or easily frightened. Born in the Bronx on October 11th, 1888, he had earned dual degrees in electrical and mechanical engineering from Cornell University, where he distinguished himself not just in academics, but as an intercollegiate fencing champion and an award-winning photographer. One of his photographs, a 3-horse fire engine team captured in perfect motion, was syndicated throughout the world. He was described by colleagues as tall, well-built, handsome, and possessed of a brilliant conversational mind that ranged easily across art, drama, economics, politics, and science. By the time he reached his late 40s, Roos had worked for General Electric, Locomobile, Pierce Arrow, Marmon, and Studebaker, where he served as chief engineer from 1926 to 1936. He was, by any measure, one of America's most accomplished automotive engineers. In 1936, after his first marriage ended, Roos married Frances Schreiner and accepted a consulting assignment with the British Roots Group, designing Humber, Hillman, and Sunbeam Talbot automobiles. The work took him to England and across Europe, including Germany. In March of 1937, he attended the Berlin Motor Show, a grand exhibition of European automotive achievement, all chrome and polished steel, and the distinctive smell of new leather and fresh paint. But that year, the motor show had transformed into something more than a showcase of cars. It had become a stage for political theatre. Adolf Hitler attended, and when he spoke, the hall fell silent. Roos listened to the speech, the aggressive rhetoric about Germany's destiny, the barely concealed threats toward neighboring nations, the fervor of the crowd's response. According to Frances, who would later recount the story, her husband's reaction was immediate and visceral. This was not political posturing. This was not diplomatic maneuvering. This was the prelude to war. Germany would invade England, Roos told her. Soon, they needed to leave. Within months, despite the lucrative nature of his consulting contract, Barney Roos returned to the United States. His colleagues thought he was overreacting. The prevailing wisdom in 1937 held that Hitler could be contained, that another European war was unlikely, that surely the memories of the Great War were too fresh for such madness to repeat itself. Roos didn't argue, he simply left. He had seen something in the Berlin Motor Show that others had missed or chosen to ignore, the marriage of industrial might and militaristic ambition. He wanted no part of it. Back in America, Roos found himself in an ironic position. He had fled from what he perceived as the industrialization of war, only to land in Toledo, Ohio, at a company that was barely industrialized at all. Willys Overland, once America's second-largest automobile manufacturer, had been devastated by the Great Depression. The company had been forced to sell off portions of its massive Toledo factory just to maintain operating capital. The workforce had dwindled. Production had slowed to a trickle. The only engine in the company's portfolio was an outdated design called the Whippet 4, a small and underpowered unit that produced 48 horsepower and had an alarming tendency to fail after just 2 to 4 hours of continuous operation. Ward M. Canaday, the president and major shareholder of Willys Overland, made Roos an offer in 1938. "Come be our executive vice president and chief engineer. Save this company. Build something that matters." The salary wasn't extraordinary, the company's prospects weren't bright, but it was in America, an ocean away from the gathering storm, and Barney Roos accepted. There's a story about Roos's early days at Willys Overland that his colleagues swore was true. Canaday, desperate to cut costs, once berated the engineering department for wasting drafting paper. Every sheet that went into the wastebasket, he lectured, represented, and money thrown away. The paper had no value once it was discarded. Roos, never one for diplomatic restraint, responded by physically lifting Canaday up and placing him in the wastebasket. The point was made. Some things have value even when they appear to have none. Remarkably, Canaday didn't fire him. Perhaps he recognized that Roos's blunt honesty was exactly what the dying company needed. What Roos needed was an engine. Everything at Willys Overland began with that pathetic Whippet 4. If the company was going to survive, if it was going to produce vehicles that people actually wanted to buy, it needed power, reliability, endurance. So for 2 years, 1938 through 1940, Roos dedicated himself to a complete modernization of the company's sole engine design. He incorporated a fully counterbalanced crankshaft to reduce vibration. He replaced the heavy cast-iron pistons with lightweight aluminum ones weighing just 340 grams each. He installed insert bearings, redesigned the lubrication system, developed a new camshaft with improved lobe profiles, and enhanced the engine's breathing capacity. Every component was examined, tested, refined, tested again. His goal was audacious, an engine that could produce 60 horsepower at 4,400 revolutions per minute and run continuously for 150 hours without failure. What he started with was an engine that produced 48 horsepower at 3,400 revolutions per minute and could barely manage 4 hours before something broke. It took him 2 full years of obsessive work. The result was an engine that Willys Overland dubbed the Go Devil, a reference to the phrase "going like the devil," though no one could quite remember the origin of that particular expression. The name stuck anyway. The Go Devil was compact, powerful, and nearly indestructible. It would go on to power not just Willys automobiles, but, unknown to Roos at the time, one of the most important vehicles in military history. On July 11, 1940, As France fell to German forces and Britain braced for invasion, the United States Army sent a telegram to 135 automotive manufacturers across America. The Army needed a new vehicle, a lightweight four-wheel drive reconnaissance car to replace the motorcycles, sidecars, and aging Ford Model T vehicles that still constituted much of its light transport. The specifications were precise and punishing. The vehicle had to accommodate a crew of 3. It needed four-wheel drive. The wheelbase could be no longer than 80 inches. Track width could not exceed 47 inches. It had to carry a 660-pound payload. And the entire vehicle, fully equipped, had to weigh no more than 1,300 pounds. That last specification was, by any reasonable engineering standard, impossible. 1,300 pounds for a four-wheel drive vehicle with a crew of 3 and significant cargo capacity defied the laws of physics as they applied to steel and rubber. But the Army wasn't finished with its impossible demands. Companies had 11 days to submit their bids. Those selected would then have 49 days to deliver a working prototype. 75 days after that, they were expected to produce 70 fully functional test vehicles. The timeline was absurd. The specifications were absurd. The entire proposal seemed designed to fail. 133 automotive manufacturers looked at the Army's telegram and declined to respond. 2 companies thought they might have a chance. American Bantam Car Company, a tiny manufacturer on the verge of bankruptcy, and Willys Overland. Ford Motor Company would join later, after being approached directly by the Army. But in that first wave, only Bantam and Willys stepped forward. Barney Roos read the specifications and did the calculations. The Spicer four-wheel drive components he would need weren't sitting on a shelf waiting to be ordered. They would have to be custom manufactured or heavily modified. The 1,300-pound weight limit was physically impossible with the Go Devil engine. He'd spent 2 years perfecting the engine alone, with its cast-iron block and necessary accessories, pushed the scales too far. And 49 days to build a prototype? From nothing? With a company that had been selling off factory equipment just to stay solvent? Legend holds that Roos stormed out of the meeting when the weight specifications were presented. He declared the project impossible and refused to participate. Whether the legend is precisely accurate or not, what's certain is that Roos initially balked. This wasn't just difficult. This was fantasy. The Army was asking for a vehicle that couldn't exist, on a timeline that couldn't be met, with specifications that contradicted each other. But then something shifted. Perhaps it was the news from Europe, images of German panzer divisions rolling across France, the reports of the Luftwaffe bombing London, the growing certainty that America would be drawn into this war whether it wanted to or not. Perhaps it was the memory of Hitler at the Berlin Motor Show 3 years earlier. Perhaps it was simply that Barney Roos had never walked away from an engineering challenge in his life, no matter how impossible it seemed. He returned to the meeting. He didn't promise he could meet the specifications. He promised he would try. American Bantam moved faster than anyone thought possible. The company was small, desperate, and possessed of a secret weapon. Carl Probst, a freelance designer from Detroit with a reputation for brilliance under pressure. Harold Christ, Bantam's chief engineer and plant manager, called Probst on July 17, 1940, and offered him the design job. Probst initially declined. The timeline was insane, the specifications contradictory, and Bantam wasn't offering a payment. But when the Army itself called and asked him to take the job as a matter of national urgency, Probst agreed. He would design the vehicle in 5 days and forego payment if Bantam didn't win the contract. Probst worked for 18 hours straight, drafting the complete plans for what would become the Bantam Reconnaissance Car, the BRC, or as some called it, the Blitz Buggy. He used every shortcut and every piece of existing automotive technology he could find. The four-wheel drive components would come from Spicer, a supplier that already manufactured such systems for other applications. The body would be minimal, just enough steel to protect the crew and mount the necessary equipment. Everything else was sacrificed in the name of weight. By July 22nd, just 11 days after the Army's initial telegram, Bantam had submitted a complete bid, including detailed blueprints. Willys Overland submitted a bid as well, but their proposal was less detailed. More importantly, they asked for more time than the Army's specifications allowed. The Army penalized them for it, literally adding a $1 penalty for each day beyond the deadline. When the calculations were finished, Bantam's bid came in lower. The contract went to the small Pennsylvania company. They had 49 days to build a prototype. What happened next would become one of the most controversial episodes in automotive history. The Army, recognizing that Bantam lacked the production capacity to build the thousands of vehicles that would eventually be needed, decided to hedge its bets. They sent Bantam's detailed blueprints, the plans that Probst had drafted, that Bantam had submitted, that represented their only competitive advantage to both Willys Overland and Ford. The Army claimed ownership of the designs since they'd been created in response to a government contract. Bantam, a small company with no legal resources to challenge the decision, could do nothing but watch as their design was handed to their much larger competitors. Bantam delivered their prototype, driven by Ralph Turner from Butler, Pennsylvania, to Camp Holabird, Maryland, on September 23, 1940. They arrived at 4:30 in the afternoon, just 30 minutes before the 5 o'clock deadline. The Army tested the vehicle for 30 days, putting it through conditions that would have destroyed most civilian automobiles. The Blitz buggy performed admirably. It was light, just 980 pounds, nimble, and remarkably fuel-efficient. But everyone knew that Bantam couldn't produce 75 vehicles per day, which was the Army's minimum production requirement. So the Army invited Willys and Ford to submit their own prototypes, giving them access to everything Bantam had developed. Barney Roos got to work. He had Bantam's blueprints, which solved many of the fundamental design challenges. But he also had something Bantam didn't have, the Go Devil engine. While Bantam had opted for a smaller, lighter engine to meet the weight requirements, Roos gambled that the Army would prioritize power over the strict weight limit. 60 horsepower versus Bantam's 40. That was a significant advantage in rough terrain when pulling cargo, when speed might mean the difference between life and death. Willys Overland delivered its prototype called the Quad for its four-wheel drive system on November 11, 1940, Armistice Day. The timing was symbolic, though no one remarked on it at the time. The design had taken 75 days, not 49, but it was complete. Ford delivered their prototype, called the Pygmy, shortly after. All three vehicles went into intensive testing through the winter of 1940 and into 1941. The testing revealed strengths and weaknesses in each design. The Bantam BRC-40, as the revised version was called, remained the lightest and most nimble, with excellent suspension, reliable brakes, and impressive fuel economy. The Ford design, designated the GP with G standing for government contract and P indicating the 80-inch wheelbase, was well built and had a clever pressed steel front grille that simplified production. But Willys's Quad, despite being heavier and arriving late, had that Go Devil engine. It had power, it had endurance. In head-to-head testing, the Willys prototype could haul more, climb steeper grades, and maintain higher speeds over rough terrain. There was just one problem. The Willys Quad weighed 2,423 pounds. The Army had revised the weight specification upward from the original 1,300 pounds, recognizing that the initial target was impossible. The new limit was 2,160 pounds. Willys was 263 pounds over. 263 pounds. About the weight of 2 fully grown men, about the weight of a dozen jerry cans of fuel, about the weight that separated Barney, Roos's design, from the largest military production contract in automotive history. The Army made its position clear in early 1941. They loved the Go Devil engine. They appreciated Willys's overall design. But if Willys wanted the contract, Roos had to cut 263 pounds without compromising structural strength, without sacrificing the engine's power, without reducing the payload capacity or the crew space, or any of the features that made the vehicle effective. £263 might as well have been 2,000. The quad was already built as efficiently as Roos knew how. Every component had a purpose. Every pound of steel was supporting something or protecting something or enabling something. Where could you cut weight from a vehicle that was already designed to be light? If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Barney. Roos spent the first months of 1941 in what can only be described as an engineering obsession. He started with the steel itself. Could they use thinner gauge steel for non-structural panels? Yes, if they found a higher strength alloy. He contacted suppliers, requesting samples of different steel formulations. He tested them, measuring tensile strength, flexibility, and resistance to fatigue. He found a lower gauge steel that was actually stronger than what they'd been using. That saved weight on every body panel. Next came the fasteners. Willys was using standard bolts and nuts throughout the vehicle, sized according to conventional automotive practice. But did every bolt need to be that long, that thick? Roos had his engineering team examine every single fastener location, calculating the actual stress loads each one would experience. Hundreds of bolts were shortened. Some were replaced with lighter alternatives. A few ounces here, a few ounces there. The wheels, the seats, the windshield frame, the tool brackets, the spare tire mount. Roos examined everything with the intensity of a jeweler inspecting a diamond for flaws. His engineers joked, though perhaps it wasn't entirely a joke, that he weighed the paint to find the lightest formulation that would still provide adequate protection against rust and weather. The work took 6 months, January through June of 1941. The engineering staff worked double shifts. Roos himself was rarely home, spending 16 and 18-hour days at the factory, testing modifications, running calculations, ordering new components, testing again. His wife Frances understood, or tried to. This was what her husband did. When he encountered a problem, he didn't walk away. He attacked it with a relentlessness that bordered on mania. Component by component, pound by pound, the weight came down. The revised Willys design, now designated the MA for Military Model A, went back to the scales. When the Army weighed it, the vehicle came in under the 2,160 pound limit, not by a comfortable margin, not by 50 pounds or 20 pounds, by ounces. Just a few ounces under the maximum allowed weight. On July 16, 1941, the United States Army awarded Willys Overland the production contract, 16,000 Willys MB Jeeps at a unit cost of $738.74 each. The design would incorporate the best elements of all 3 prototypes: Bantam's engineering concepts, Willys's Go Devil engine and chassis design, and Ford's front-end configuration with the now iconic slat grille. The standardized design was designated the Willys MB. Ford, recognizing that Willys alone couldn't meet the production demands, was also contracted to build the same vehicle under the designation GPW, with the W acknowledging that they were building to Willys's specifications. Barney Roos had done it. The impossible vehicle existed. The vehicle that couldn't be designed in 49 days had been designed. The vehicle that couldn't weigh less than 2,160 pounds weighed less than 2,160 pounds. The vehicle that Roos had initially walked away from as fantasy was now heading into production. And then, on December 7, 1941, Japan attacked Pearl Harbor. America entered the war. The war that Barney Roos had fled in 1937. The war he thought he could escape by returning to America. The war that had now become his war, whether he wanted it or not. The Army immediately increased its orders. Massively. Exponentially. 16,000 jeeps became 60,000, became hundreds of thousands. The Willys Overland plant in Toledo, which had been slowly dying just 3 years earlier, now had to transform itself into a wartime production facility operating at a scale that would have been unimaginable in peacetime. 3 shifts, 24 hours a day. The assembly line could never stop. The demand was infinite. The timeline was yesterday. Ford's River Rouge plant, along with facilities in Dallas, Louisville, Chester, and Edgewater, began producing GPWs. But the heart of Jeep production remained in Toledo, at the factory where Barney Roos had spent 2 years perfecting an engine that could run for 150 hours without failure. Now that engine needed to be built not in ones or twos for testing, but in thousands, tens of thousands, hundreds of thousands. The transformation of the Toledo plant was a story of its own. Much of the workforce was new women who had never worked in a factory before, men too old for military service, teenagers barely out of high school. They had to be trained not just in basic assembly techniques but in the specific demands of military production. Tolerances mattered, quality mattered. A loose bolt in a civilian car was an annoyance. A loose bolt in a Jeep heading to combat could be fatal. So, the training was intensive, the supervision constant, the quality control rigorous. The assembly line itself had to be redesigned for speed. In conventional automotive production, vehicles moved from station to station where workers performed specific tasks. But the sheer volume of Jeeps needed meant that even conventional assembly line techniques weren't fast enough. Willys engineers worked with industrial efficiency experts to streamline every movement, eliminate every wasted motion, and reduce every pause. Components were staged near the line so workers didn't have to walk far to retrieve them. Tools were arranged in optimal sequences. Workstations were designed so that multiple workers could perform simultaneous operations on the same vehicle. Parts came from suppliers across the industrial Midwest. Frames from Midland Steel Products, wheels from Kelsey Hayes Wheel Company, axles and transfer cases from Spicer Manufacturing. The supply chain had to function with absolute reliability because a shortage of any single component would stop the entire line. Contracts specified not just quantities, but delivery schedules measured in days and sometimes hours. Trucks arrived at the Toledo plant in continuous streams, unloading their cargo directly onto the factory floor, where it would be integrated into vehicles within hours. The Go Devil engines came from a dedicated engine plant within the Toledo complex. This was Roos's domain, where the 2 years of development work had to be translated into mass production. The aluminum pistons, the counterbalanced crankshaft, the insert bearings, the precise valve timing, all of it had to be manufactured to exacting specifications at unprecedented speeds. The engine plant operated on the same 3-shift 24-hour schedule as the main assembly line. The distinctive sound of those engines being tested, a raw, mechanical growl that spoke of power held barely in check, became the soundtrack of wartime Toledo. By late 1942, production had ramped up significantly. By early 1943, the Toledo plant was producing hundreds of Jeeps per day. And by late summer of 1943 August, specifically, they reached a production rate that seemed to violate the laws of industrial possibility. 1 Jeep every 80 seconds. Consider what that means. Every component of the Jeep, the frame, the axles, the transmission, the transfer case, the engine, the body panels, the seats, the steering wheel, the instruments, the lights, the tires, the windshield, every bolt and nut and wire, approximately 1,540 individual parts had to come together in perfect sequence in less time than it takes to soft-boil an egg. The coordination required was staggering. If any supplier was late, the line stopped. If any worker made a mistake that damaged a component beyond quick repair, the line stopped. If any tool broke or any welding machine malfunctioned, the line stopped. But the line almost never stopped. The workers learned to function as a single organism, each person's movements timed to synchronize with everyone else's. The woman installing seats knew exactly how long she had before the next jeep arrived at her station. The man welding the body panels knew exactly how many welds he could complete in the time available. The quality inspector checking the engine installation knew exactly what to look for and how quickly to spot problems. Muscle memory replaced conscious thought. The work became a kind of industrial meditation, where the rhythm of the line dictated everything. Barney Roos walked that factory floor regularly, watching the miracle he'd helped create. He saw elderly men whose hands shook with age, nevertheless performing precision work with absolute reliability. He saw women barely 20 years old operating welding equipment with the confidence of veterans. He saw teenagers, boys and girls who should have been in college instead building the machines that would carry American soldiers through North African deserts and across Pacific islands and eventually into the heart of Germany itself. The irony was not lost on him. In March of 1937, he had fled Berlin because he wanted nothing to do with the coming war. He had returned to America believing he could escape it, that the Atlantic Ocean would keep the conflict safely distant, that he could spend his remaining career building civilian automobiles for a peaceful market. Instead, by August of 1943, he had become one of the principal architects of America's war machine. The Go Devil engine he'd perfected in the quiet years of 1938 through 1940 was now powering the most important vehicle in the Allied arsenal. The vehicle he'd initially declared impossible was now rolling off the assembly line faster than any vehicle in history. Every 80 seconds, another weapon against Hitler. Every 80 seconds, another tool for the war Roos had tried to avoid. Every 80 seconds, another piece of evidence that you cannot flee from history, you can only choose which side of it you'll stand on when it arrives. The jeeps went everywhere. To North Africa, where General Patton's forces used them to pursue Rommel's Afrika Korps across hundreds of miles of desert. To the Pacific, where Marines loaded them onto landing craft and drove them directly onto hostile beaches, using them to transport ammunition, evacuate wounded, and mount machine guns for mobile fire support. To England, where they staged an invasion of Europe. Under the Lend-Lease program, 50,000 jeeps were shipped to the Soviet Union, where they were used on the Eastern Front against the same German forces that had paraded through Berlin when Roos was there in 1937. The jeeps proved versatile beyond anyone's initial expectations. They were fitted with stretchers and used as ambulances. They were equipped with radio equipment and used as mobile command posts. They were armed with 50 caliber machine guns and used as cavalry substitutes for reconnaissance and rapid reaction fire support. They were fitted with railroad wheels and used to scout rail lines in occupied territory. They were modified with deep water fording kits and driven through rivers. They were equipped with desert cooling systems and driven through sand dunes. They were fitted with snow treads and driven through blizzards. Soldiers developed fierce emotional bonds with their jeeps. Unlike tanks or trucks, which were impersonal machines operated by crews, a jeep was often assigned to a specific driver who maintained it, modified it, named it, and came to regard it almost as a living thing. There are countless photographs from the war showing soldiers with their jeeps, the vehicles festooned with personal touches, painted names, unit insignia, kill marks, good luck charms. The jeeps that survived combat often bore scars, bullet holes, shrapnel damage, hastily welded repairs. These weren't just marks of damage, they were marks of survival, shared between man and machine. General Eisenhower, in his post-war assessment of the weapons that had contributed most to Allied victory, listed the Jeep alongside the C-47 transport aircraft, the bazooka, and the atomic bomb. General George Marshall called it America's greatest contribution to modern warfare. Soviet generals, receiving their Lend-Lease Jeeps, praised their reliability and adaptability to Russian winter conditions, high praise from an army that generally preferred its own equipment. British forces, initially skeptical of American engineering, came to depend on jeeps for desert operations where British vehicles proved less reliable. The production numbers tell their own story. By the end of 1943, Willys had produced more than 200,000 Jeeps. Ford had added another 100,000 GPWs. Production continued through 1944 and into 1945. When the war in Europe ended in May of 1945, total Jeep production had reached approximately 647,870 vehicles. Willys accounted for 363,000 of these. Ford produced 280,000. American Bantam, the company that had designed the original prototype, had been limited to 2,675 Jeeps before being shut out of production entirely. They pivoted to building Jeep trailers and other military equipment, but the company never recovered from losing the contract that should have saved it. The end of the war in August of 1945 brought a question that many defense contractors faced. What do you do when the demand for your product suddenly disappears? Willys Overland had the answer. They'd been preparing for it since 1944, when it became clear that Allied victory was inevitable. The Jeep had proven itself in military service, but could it find a place in civilian life? The answer came in the form of the CJ2A, where CJ stood for Civilian Jeep. Introduced in late 1945, it was essentially a Willys MB with modifications for peacetime use: a tailgate, a side-mounted spare tire, better seats, a hand-operated windshield wiper instead of a vacuum-powered one, an outside fuel cap. The retail price was $1,090, not cheap, but reasonable for a vehicle that promised to be as reliable and versatile as its military predecessor. Willys marketed the CJ2A initially to farmers, recognizing that rural America needed rugged, practical vehicles for work rather than transportation. The advertisements called it the all-around farm workhorse, claiming it could do the job of 2 draft horses while operating for 10 hours a day without overheating the engine. The Go Devil engine that Barney Roos had, designed for military endurance, turned out to be perfect for agricultural applications. Farmers could attach plows, harrows, mowers, and other implements to the Jeep's power takeoff system, turning it into a mobile power source as well as a vehicle. But something unexpected happened. Returning veterans, who had learned to trust the Jeep in combat, bought them not just for work but for recreation. They took them hunting. They drove them into the mountains for fishing trips. They used them to access remote areas that conventional cars couldn't reach. The Jeep, designed as a military reconnaissance vehicle, became the foundation of what would eventually be called recreational off-roading. It created an entirely new category of leisure activity. The civilian Jeeps sold well. Not spectacularly, Willys was never going to compete with Ford or General Motors in terms of sheer volume, but steadily, reliably, profitably. The company introduced variations: a Jeep station wagon in 1946, which was the first mass-produced station wagon with 4-wheel drive; a Jeepster in 1948, styled more like a sporty car than a utility vehicle; a pickup truck version. Each iteration used some variation of the Go Devil engine, or its successor, the F-head Hurricane engine that Roos helped develop. Barney Roos continued working at Willys after the war, though his role gradually shifted from hands-on engineering to consultation and advisory work. In 1953, Kaiser Motors acquired Willys Overland for $63 million, primarily to gain control of the Jeep brand and the international licensing agreements that Willys had established with manufacturers in countries ranging from India to Brazil. Roos retired after the Kaiser acquisition, though he maintained a nominal relationship with the company until his official retirement in 1958. He was 70 years old, and he had spent the last 20 years of his career at Willys Overland, transforming a dying company into the producer of one of the most iconic vehicles in history. On February 12, 1960, Barney Roos was returning by train from a business meeting in Reading, Pennsylvania, to his home in Bronxville, New York. He fell ill during the journey. He disembarked at Philadelphia and was taken to Temple University Hospital. He died the following day, February 13, 1960, at the age of 71. The New York Times obituary noted his work on the Jeep, but it was a brief mention in a modest article. The man who had designed the engine that powered nearly 400,000 military vehicles in World War II, the man who had solved the 263-pound weight problem, the man who had made the 80-second production rate possible, passed from history with little fanfare. But the Jeep lived on. The Go Devil engine, with its counterbalanced crankshaft and aluminum pistons and insert bearings, continued to power Jeeps through the Korean War and into the 1960s. The basic design that Roos had helped refine in 1941 remained largely unchanged through decades of production. The CJ series, which descended directly from the Willys MB, continued through the CJ2A, the CJ3A, the CJ3B, the CJ5, the CJ6, and the CJ7, finally ending production in 1986 when it was replaced by the Jeep Wrangler. But the Wrangler was simply another evolution of the same concept, a direct descendant of the vehicle that Karl Probst had sketched in 18 hours and Barney Roos had perfected through 6 months of obsessive weight reduction. The recognition came slowly but eventually arrived. In 1944, the New York Museum of Modern Art included a military Jeep in its permanent collection as one of 8 automobiles representing genuine expressions of machine art. It was a remarkable honor for a vehicle that had been designed purely for function, with no consideration for aesthetics. But the museum's curators recognized something important. Sometimes form follows function so perfectly that the result becomes beautiful. The Jeep's distinctive silhouette, the flat hood, the slat grille, the exposed wheels, the fold-down windshield had become instantly recognizable around the world. Enzo Ferrari, the legendary Italian automotive designer, reportedly called the Jeep the only true American sports car, a backhanded compliment that nevertheless acknowledged the vehicle's purity of purpose and execution. In 2010, the American Enterprise Institute called the Jeep one of the most influential designs in automotive history. This was 70 years after the Army had issued its impossible specifications, 70 years after Karl Probst had worked through the night to draft the initial plans, 70 years after Barney Roos had spent 6 months cutting 263 pounds from an already efficient design. The influence was undeniable. Every modern SUV, every four-wheel drive recreational vehicle, every attempt to combine utility with mobility can trace its lineage back to that collaboration between Bantam, Willys, and Ford in 1940 and 1941. The military legacy was equally significant. The Jeep served in every major American military operation from World War II through the present day. Modified versions fought in Korea, where the terrain was even more challenging than European battlefields. They were used in Vietnam, though by then they were being supplemented and eventually replaced by the M151 MUTT, which was itself based on Jeep design principles. The modern military equivalent, the HMMWV or Humvee, is heavier and more specialized, but it serves essentially the same role that the Willys MB served 80 years ago: mobile, versatile, reliable transport for personnel and light equipment. But perhaps the most significant, legacy is cultural rather than mechanical. The Jeep entered the American consciousness as a symbol of certain values: practicality over pretension, reliability over luxury, versatility over specialization. It represented the idea that good design solves problems rather than creating them, that engineering should serve human needs rather than corporate marketing strategies. The fact that it was designed by committee, that it incorporated ideas from multiple companies and multiple engineers, that it was refined through testing and failure rather than emerging perfectly from a single visionary mind, made it quintessentially American in a way that more polished designs could never match. Return for a moment to that factory floor in Toledo in August of 1943. One Jeep every 80 seconds. The line never stops. The workers moving in practiced synchronization. The sound of the Go Devil engines being tested in the adjacent building. the smell of fresh paint and hot metal and the faint ozone scent of welding. Barney Roos watching it all, this man who had fled from Hitler's Berlin and wound up building the machine that would help bring Hitler down. What was he thinking? We can't know, not with certainty. But we can imagine. Perhaps he thought about the impossibility of it all, how the vehicle he'd initially rejected as fantasy was now being built at a rate that defied industrial logic. Perhaps he thought about the weight reduction, those 263 pounds that had consumed half a year of his life, and how that seemingly minor achievement had enabled everything that followed. Perhaps he thought about the workers, these people who had stepped up when their country needed them, who had learned skills they never imagined they'd need, who were now producing miracles as a matter of routine. Or perhaps he thought about Berlin in March of 1937, hearing Hitler speak, recognizing the coming war, making the decision to flee. That decision had been based on the desire to avoid war, to stay out of the conflict, to remain safely distant from the carnage. But you cannot flee from history. You can only choose how you'll participate in it when it arrives. Roos had chosen to participate by building engines, by solving impossible problems, by making the 80-second production rate possible. The war ended. The soldiers came home. The jeeps that had survived combat were either shipped back to America or sold as surplus to foreign governments or simply abandoned in place, no longer needed. But the concept lived on, the idea that you could build a vehicle that was simple, reliable, powerful, and adaptable to virtually any situation. That idea had been proven beyond doubt. Every subsequent attempt to build such a vehicle, military or civilian, had to be compared to the Willys MB. Most failed the comparison. In the decades after the war, historians and journalists occasionally tried to determine who deserved credit for inventing the Jeep. Was it American Bantam, which had submitted the first complete design? Was it Karl Probst, who had drafted those plans in 18 hours? Was it Willys Overland, which had won the production contract? Was it Barney Roos, who had solved the weight problem and designed the engine? Was it Ford, which had contributed the final body design and produced nearly half of all wartime Jeeps? Or was it the Army, which had issued the specifications in the first place? The answer, unsatisfying to those who prefer simple narratives, is all of them. The Jeep was designed by committee, refined by competition, built by multiple companies, and tested by the worst war in human history. It succeeded not because of a single genius, but because of many talented people working under impossible constraints and somehow, improbably, succeeding. But if we're being honest, the person most responsible for making the impossible routine, for transforming the fantasy of July 1940 into the production line of August 1943, was Barney Roos. Not because he designed the entire vehicle, he didn't. Not because he ran the factory, he didn't. But because when confronted with the statement, "You need to cut 263 pounds from this vehicle without making it weaker," he didn't say it was impossible. He didn't walk away. He spent 6 months finding those 263 pounds, ounce by ounce, component by component, until the scales finally tilted in Willys's favour. That obsessive attention to detail, that refusal to accept defeat, that willingness to examine every bolt and every panel and every fraction of an ounce, that's what made the 80-second production rate possible. Because you can only build something impossible if you first figure out how to make it possible, and then you figure out how to make it routine, and then you figure out how to make it fast. One Jeep every 80 seconds. From impossible to routine in 3 years. From fantasy to the most important vehicle in military history. From a dying company in Toledo to a symbol recognized around the world. The man who fled Hitler's war in 1937 helped end that war in 1945 by building the machine that carried Allied soldiers to victory. The irony is perfect. The tragedy is that Barney Roos probably understood it completely. You cannot escape history. You can only build the tools that shape it. And if you build them well enough, they'll still be shaping history 80 years later. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.